Hey guys, what's up everybody? Welcome and welcome back again to another video tutorial from the Apex Academy of Mathematics. We are learning the language of the universe begins here. My name is Akin, otherwise known as Apex Selenium, and on my channel we help students to master their fundamentals, we rebuild them, and we unlock the genius that lies within them. Alright, now if this is the first time here on my channel, please go ahead. If you are liking my content before or even now as we speak, go ahead and of course smash the like button, turn on your post notification bell, and smash that subscribe button for future tutorial videos. All right, wonderful. Now this again is another fundamental video, but it's to the benefit of all students doing CXE, GCE, CAPE, EDXL exams, GSCE exams. No matter what kind of math you're doing, on this channel we aim to build all different types of students right across the world. So of course go ahead and enjoy the content so far. All right, good. So without further ado, let's jump right into the video. And in this video we're going to be talking about the different four different principles here. All right, I've combined them for you here. All right, so factors of a number, multiples of a number, lowest common multiple, and highest common factor, and we want to find a relationship between them. Now I've arranged these in order because I really want to show you why knowing this will help you to find this, and knowing multiples will help you to understand LCM. All right, now this might be a little bit lengthy video, so please of course forgive me. Stay as long as you can and learn as much as you can from this content. All right, I'll try to be as precise and clear as possible. All right, so let's jump into it. So first we're going to define what is a factor, or what is referred to as a factor of a number. All right, so factors of a number are all the possible numbers that are exactly divisible into a specific number. Now say for example we have a number like say 24. What we're trying to find out are all the numbers that can go into 24 without leaving a remainder, all the possible numbers. All right, so that's what we refer to as factors. Almost when I was learning this, my teacher always say she always use reference to a real life perspective, and she always say what are the factors that affect crime? What are the things that would cause crime to occur? And I would list all the factors for her, and then she would make a relationship between that and say what are all the numbers that can go into 24 without leaving a remainder. So that kind of reference made sense to me. I'm not sure if it made sense to you. Factors are basically what goes into something, what causes something to happen. All right, so it's very important you understand that. So it says here that factors of a number are all the possible numbers that are exactly divisible into a specific number without leaving a remainder. All right, so now factors are easily determined by dividing the number by the members of n. Now if you watch my previous video, or my most recent video on sets of numbers, the link is provided in the description box below. You can check that out right down in the description. All right, we're going to talk about the numbers that belong to the set n, and n represent natural numbers, which of course we say that natural numbers start at 1 and ends at infinity. So the members of n are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on and on and on. Now if you want to find out what the factors of a specific number are, what you need to do is to, whatever the number is, let's say for example the number 30. All right, or no, say the number 50. Let's take for example, because I do have 30 here as an example. So number 50, first we can do is to divide 50 by 1. So we know that 50 is a factor of 50. All right, so that's 1. We can try, let's think about what number can you think can go into 50. So 50 divided by 2, that will give us 25. So 25 is a factor of 50. 50 I don't think can be divided by 3. So even when you're dividing a number by a natural number, you can say 50 divided by 3 is that doesn't look possible. Let's try 50 divided by 4. Not quite exactly. Let's try 50 divided by 5. That gives 10. All right, so as you begin to divide the number by each of the natural numbers going down, it really still becomes like a feel thing. It's like almost like you already know your timetable. So this technique, of course, you may see it in textbooks, but I really don't really recommend it. All right, it's more of kind of knowing your timetable to an extent where you know what number can go into a number. Clearly, if I were to pick a number like, say, for example, 22, and I should say divide that 22 by 5, you'd clearly know that 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. Another 5 will go past 22, and we're already at 20. So I don't think 5 can go into 22. So, I mean, finding the factors are going to be relatively easy. After doing it so many times, if your timetable is not really good, then that's when you will struggle to find the factors. But if you have your timetable to a certain extent, they are not very difficult to find. But what I always do too is that I also have a neat little trick here where I try to find half of the number. All right, now if I ask you to find the factor of a specific number, let's say for example 18. Once I divide 18 by 2, I get 9. I know that the factor, the second to last factor is going to be 9. The last factor will be the number itself, and then I begin to find the factors of 9, because all the factors of 9 are also going to be factors of 18, because 9 can go into 18. All right, so that's what I always do. But this is really more like I already think you know this, but you can clearly see here that it's just kind of the numbers that go exactly into, yeah. So it's just 1, 2, 4, 5, 8, 10, 20, 40. So 1 goes into 40 times, 2 goes into 40 20 times, 4 goes into 40 10 times, 5 goes into 40 8 times, and you begin to meet right here in the middle. So it's kind of, I guess I would want to say it's self-explanatory. All right, so for the number 30, it is 1, 2, so 1 goes into 30 times, 2 goes into 30 15 times, 3 goes into 30 10 times, 5 goes into 30 6 times. So once you begin to meet very close to the last number that you divided by, then you know you have reached, and you just kind of check to see if there's any number in between that could possibly go into 30. All right, so I hope you guys kind of understand that on an extent. All right, let's jump into the next one, which we refer to as multiples of a number. So multiples of a number are all the possible numbers that a specific number can be divided into. All right, so multiples of a number are all the possible numbers that a specific number can be divided into. So what we're looking at here is, say for example, we want to find the multiples of, say, 6. What we're looking at are all the numbers that 6 can go into. Remember up here we said that it is all the numbers that can go into 24. Multiples are basically all the numbers that this can go into. So 1 is going into 24, and 1 is where 6 is going into those numbers. So here you will see that factors are finite, multiples are infinite. You cannot list all the multiples because 6 can go into infinite amount of numbers, all right, but only a certain amount of numbers can go into 24. All right, so it's really good that you understand the concept. Remember, let's just write it down here for you. Factors is what go into them, and multiples is what they can go into. All right, so 1 goes into and 1 goes, call it, say, if there's a word, out to. So out into numbers, into numbers. All right, so it's really good that you kind of have that idea. All right, so hope that kind of helps a little bit. All right, so possible numbers specific that can divide into. Now these set of numbers, as we see here, are infinite and can be easily determined by multiplying each of the members by n. N, of course, we know that are natural numbers, so clearly you can see if I want to find the multiple of any number, I just take that number and multiply it by each of the natural numbers. So if I want to see find the multiples of 6, we know that of course 6 times 1 6, 6 times 2 12, 6 times 3 18, 6 times 4 24, 6 times 5 30, 6 times 6 36, and it goes on like that. Now as I said before, it is infinite, but there are cases where sometimes you're given a condition, and that condition states that you need to list the multiples between A and B, or list the multiples between 40 and 95, or say 100 and 350 of a specific number. All right, sometimes it have a tendency to say inclusive of the number itself, or it might say exclusive of the number itself. So it really depends. If it says inclusive, then you have to include the number 5. It says exclusive, you have to use the next number apart from 5 that is a multiple of 5. So here you can see here 5 is 5, 10, 15, 20, 25. You just keep going up by 5, and then 7, 14, 21, 28, 35. You just keep going up by 7. So learning how to find multiples of a number is also a really nice way of memorizing your timetable. Your timetable is really essential to becoming a strong math student. I know my timetable up to 12, but because I know it so well, I can definitely use it to my advantage to know my 35 times table, my 25 times table, my 17 times table, because the idea behind the timetable is that whatever the timetable is, you just keep adding that number to the previous result. Yes, so 16 times 1 is 16, 16 times 2 is 32, 16 times 3 is 48, 16 times 4 is 64, and it goes on and on and on like that. All right, so 16 times 5 is 80, and you just keep adding 16. So it's really fast addition, all right, or repetitive addition. All right, so I hope you guys got that concept as it relates to multiples. Now, how can we connect the idea of factors of a number and multiples of a number to lowest common multiple and highest common factor? Notice that here, lowest common multiple has the word multiple in it. So it must mean here that the number is connected to the multiple of a number. Right, it must mean that it's connected to the multiple of a number, lest it would not have the word here multiple in it. And HCF here, if it has the word factor, it must mean that that's connected to that in some extent, and this is connected to that in some extent. Let's take a look at how they're related. So for the highest common factor here, let's look at the definition. The highest common factor is the highest number that is exactly divisible into a set of number. Remember, we said that factors, let's write it here. Remember, I told you earlier to remember that factors is what goes into them. So therefore, it's no different here. What we're looking at are all the numbers that can go into 12. That's what is called the highest common factor. All right, all the numbers that can go into 18, all the numbers that can go into 24, because factors represent all the numbers that can go into a specific number. All right, now because you're not finding just the factor of a number, but you're finding the common factor of a set of numbers, it would mean that whatever these set of numbers are, you're going to be required to list out all the factors of each of these numbers. All right, let's continue to read the definition here. So that's how it's connected. To determine this highest common factor, this number, all the factors of the set of numbers must be listed. I've listed here 12, 1, 2, 3, 4, 6, 12, 18, 1, 2, 3, 6, 9, 18, 24. I've listed them right here for you. All right, it goes on to say, then the number that is the highest and most common will be your HCF. So I've used some different coded inks here for you. For the number 12, we know that these are the factors. For the number 18, these are the factors. For the number 24, these are the factors. But here we have highlighted the number 1 in green. It is common to all three. 2 is also common to all three. 3 is common to all three, and 6 is common to all three. So we have 4 possible common factors, but we are looking for the highest of the 4, and the highest of the 4 is 6. So clearly you can see that is how you find the HCF. So if you're given a set of numbers, whether it be 2 or 3 or 5 or 10, you are going to have to list all the factors of each of those numbers and circle the ones that are common, and then identify the one that is the highest of the ones that are common. All right, now after a while, finding the HCF becomes second nature, because of course you're doing other subsequent fundamental topics, so this will become second nature to you. So I hope you guys got that demonstration of how to find your HCF. All right, good. So notice here that the HCF here is always less than the lowest number, or it is usually less than or equal to the lowest number in the set. Sometimes the HCF might be the lowest number in the set, or it might be a number lower. All right, because it is a factor, it cannot be greater than the number. All right, good. All right, so let's look at lowest common multiple here. All right, and it says here that to determine the lowest common multiple, we arrange each number in a rectangular array of rows and columns. This will be demonstrated over here on the next page that I have here for you. I'm going to explain this table in a moment, right? All right, so we arrange the numbers in a rectangular array of rows and columns. Now, in each column at the top, we place each number and divide each number thoroughly by the lowest prime number until there's a remainder of 1. This will all make sense in a moment, so not to worry about that. Now, these numbers are not exactly divisible by the selected prime number. It will be left alone until there is a chosen divisible prime number. Now, this technique here, all right, so first of all, LCM is used most of all when we're doing fractions. All right, and to find most LCM, you're going to find out that it's quite easy, because most of the time you're not required to find the LCM for no more than 2 or 3 numbers. But here we're looking at using this technique here to find LCM for any combination of numbers, no matter how they may look. I do have one example over here for you, and here we want to find is the LCM of 6, 15, and 30. Now remember, we said that for multiple, we said earlier that multiple is basically what they can go into, right? So what we're looking at is what 6, 15, and 30 can all go into. We want that very one single number that they can go into. So that's really what we want to find out. All right, good. So let's have a look at that. Now, there are going to be some easy numbers in the future, but there are examples in textbooks, assignment papers, introduction to exams, introduction to mathematics, where they're testing your timetables or your ability or your fundamental skills. So we want to make sure that we have a little weapon in our back pocket to help us. All right, so for 16, 15, and 30, we're going to choose a prime number. Let us choose the prime number. The lowest, of course, I always choose is, of course, the number 2. So we're going to put the 2 here, and we're going to say 2 into 6 goes 3 times. Now, in the previous statement here, we said that the numbers that are not exactly divisible by the selected prime number will be left alone. Now, since 2 is not exactly divisible into 15, we're going to leave the 15 alone until there is a number that we select in the next row that can go into 15. Now 2 can go exactly into 30, so that will go 15 times. All right, now remember that the numbers that you're choosing over here, they have to be prime numbers. All right, they have to be prime numbers, so we want to establish that for you. Let's say another prime number. Let's say 3. All right, so we're going to choose the number 3. So 3 into 3, 1. So we have attained one part of our objective. We have a remainder of 1 here. So 3 into 15 goes 5 times, and 3 into 15 goes 5 times. All right, now we're going to choose another prime number, and perhaps this is going to be the final prime number. So here we have 5 into 1. Well, of course 5 cannot go into 1, so we're going to leave the 1 alone, and 5 into 5 goes 1 time, and 5 into 5 goes 1 time. So we have achieved our ultimate objective here of getting a remainder for all the numbers of 1. All right, now once that happens, it is really easy to find the LCM, because we're just going to multiply simply. We're going to just multiply these 3 numbers here. 2 times 3 times 5. So 2 times 3 times 5, and that will give us an answer of 30. So the LCM of 6, 15, and 30 is equal to 30. All right, now there are this is just a little technique that you can use to help you to solve LCM questions. All right, but most of the time when you're using the LCM technique, it won't require you to do this. It will only require you to do this whenever you're doing a direct LCM question, which the teacher or the instructor may try to make the question a little bit difficult than usual. All right, so I do hope you have that technique. All right, so try it. Make a list of numbers randomly selected and use this technique. Watch this video and you can see exactly how to apply the skill, and then you're going to find out that this is to your benefit. All right, now that brings us to the end of this tutorial video from the Apex Academy of Mathematics. Do take care, and I'll see